Hello students, a huge welcome to the today's live session on the chapter Polynomials. My name is Lalita Devi, your senior math faculty. In today's session, we are here to help you to understand the concepts of polynomials clearly. If you have any doubts or if you want to explore the concepts further, you can use the chat or comment section that is available for you. Now, I think we are on time, but let's wait for 1 or 2 more minutes so that our remaining students will join. Okay? Yes. Meanwhile, you can get ready with your notebook and pen. And whenever you think that, okay, fine, this is the one I need to take a note, then you can take a note. And I will also help you to take the note. Okay? Yes, I think we have waited for enough time. So without any delay, let's dive into our today's session. So coming to the today's class, we will discuss about the grade 10 polynomials chapter. So before moving to that, let's see what are the topics we are having in the chapter polynomials. Okay, so coming to here, first of all, we will discuss about the introduction. So first of all, we will discuss about the introduction and next standard form of your polynomial and next value and zero of your polynomial and degree of your polynomial and types of polynomial. And in types also we will discuss about two types, based on terms and based on degree. And next we will discuss about graphical representation of your polynomial. Okay? And next we will discuss about the simple relation between the zeros and coefficients of your polynomial and division algorithm, factor and remainder theorem, and finally it is the summary, which is like a very easy topic. Okay, so entirely polynomial is the easiest chapter because in our grade 10 we mostly concentrate on the degree of your polynomial and a graphical representation and relation between zeros and coefficients. Whatever the remaining we are having like value and zero and types of polynomial, division algorithm, factor and remainder theorem, these all we have already learned in our grade 9. Okay, so no need to worry, these are the topics that we already learned in our grade 9. And coming to here, mostly we will concentrate on degree, graphical representation and relation between. Okay, so let's explore them in detail. But before moving to that, we conducted an exam. So I think you are also have gone through the pre-board exams, right? So like that, we have conducted the pre-board exams and I am having the two students named Tom and Jerry. So who are both friends and enemies. Now they want to compare their marks and they came to me and asking about the marks. I told that marks of Tom are 5 more than the marks of Jerry. I told only this simple statement. Marks of Tom is 5 more than the marks of Jerry. So they got confused. What is this? So they asked me, if you try to break that, then you will be getting an idea. So I am going to take Tom marks and Jerry marks. Okay. So Tom marks are 5 more than Jerry. It means what? First I need to know what are the marks for Jerry, right? I don't know what are their marks. So let's consider X. And I told for Tom it is 5 more than Jerry. So it will become your 5 more. It means 5 plus. So that becomes your X plus 5. Oh, if you see here, we are using the variable. It means nothing but a letter and a constant. That is nothing but a number, right? So the letter that we are using here, I am going to call it as a variable. And the number, which is a fixed value we are having here, that will become your constant. Okay, now how can we say that variable and constant means? In grade 8 we learned about the algebraic expressions, right? There in algebraic expressions we learned about the variables, constant and coefficient. So now let's discuss or let's recap once again about the basic terms of the polynomial. Those are nothing but, as I told you, that an expression. and if we are having an expression with the terms, okay, just consider we are having the variables and constants. What is meant by variable? Variable is the letters. You can take any of your letters, x, y, p, q, like that. And constant means simply fixed numbers. It means you can take 2, 3, 4, 5, 0, and negative numbers also you can take. And coming to the mathematical operators, that are your plus and minus. Okay, it means if you are taking a variable x and if you are taking a constant 2, and if you're combining them using a mathematical operator plus, now this will become your algebraic expression. Okay, now this is your algebraic expression. Now what is meant by the terms in your algebraic expression means you can consider variable as a term, okay, and you can consider constant as a term. So this is your term 2 and this is your term 1. Now let's take another example, 3x plus y plus 4. This is also an algebraic expression because it is having a constant and the variable and the mathematical operators between them. Now 3x is also a term because you can take the one which is like the one constant multiplied by variable as also term. Okay, so finally we can say that term is nothing but a variable. It can be a variable or a constant or the combination of both variable and the constant. Okay, now coefficient. What is meant by the coefficient? It was simply if I need the coefficient of t in this term, just ignore the t and whatever the remaining you are having, that will become your coefficient. So for example, in this term I need the coefficient of x. So what is the coefficient of x will become? So in this term I need to ignore the x and whatever the remaining part I am having, that is 3 I am having, this will become your coefficient of x. Okay, now I am having here y. Then how can we identify the coefficient of for that terms? For these term, if you consider how I will get y can be written as 1 into y, right? So now if I need the coefficient of y, if I need the coefficient of y, then how can we write? So ignore the y term and what we left with? We left with 1. So 1 will become the coefficient of y. Okay. So first major mistake every student will think is, I am having here y, before y I am not having any number, so the coefficient will be 0. No, that is wrong. Okay. So y can be written as your 1 into y, so that coefficient of y will become 1. Right. So why I am explaining the coefficient in detail means you will understand its importance in the relation between the zeros and coefficients of your polynomial. Okay. So make sure that if you are not having any number in front of the variable means its coefficient will be the 1, not 0. Please understand that. Okay. Now moving to the next. This is your algebraic expression, that is fine. What about the polynomial? So how can we get the polynomial from the algebraic expression? It's very simple. Now I am taking the same example x plus 2. Okay. Now I just want to write the power. It means exponent for my variable. So I am taking it as my x square plus 2. Now I can say that this x square plus 2 is a polynomial. Why? Because an algebraic expression will become a polynomial if the exponent on a variable, okay, any variable you can take, either x, y or p or q, any variable you can take for the for the algebraic expression. If the exponent of any variable is a whole number means it starts from 0, 1, 2, 3, 4 and so on, right? So if you are having the exponent, it means if you are having the power of any variable as the whole number for an algebraic expression, then it becomes the polynomial. Okay, so for the whole numbers we can say other form as the non-negative integers. So don't get confused. Non-negative integers or whole numbers means same. Non-negative integers means what we will take? We will start with 0 and the positive integers, right? Same as our whole numbers only. So whole numbers and non-negative integers are same. Okay. So finally we can say that for an algebraic expression, if you are having the exponent of any variable as a whole number, then it will become your polynomial. Okay. I have one trick question. So can we say that all algebraic expressions are polynomials? Yes or no? So think once. Can we say that all algebraic expressions are polynomials? No. Why? Because in algebraic expressions we might be having the negative power. So we can't say that all algebraic expressions are polynomial. But we can say all polynomials are algebraic expressions. Okay. Now clear about the difference between your algebraic expressions and the polynomials? Fine. So I think we are not having any questions till now. So let's go into the next. Next we will discuss about the standard form of a polynomial. It means when we can say that an algebraic expression is a polynomial. Standard form means simply you can take any values randomly and you can place that, so you will be getting some random polynomials. Okay. Now coming to the standard form of your polynomial, we will start with the representation of your polynomial, that is your p of x. So simply I am saying that p of x, which is nothing but a polynomial which is having the variable x. Okay, so p of x is simply polynomial in variable x. Okay, so it is variable x. Now this polynomial can be written as an x to the power n plus an minus 1 x to the power n minus 1 and so on. A2 x square plus a1 x plus a0. This is such a big expression, but it is in standard form, so you might be thinking like that, but I will make it short for you. For example, I am having 3x square plus 2x plus 1. Okay, if I am taking this is as my polynomial, now I started writing my polynomial from the highest power of the variable and I am going to decrease the power. Okay, so now here x is the variable and 2 is the power of my, it means exponent of my variable, and 3 will become our coefficient. Okay, and 1 will be your constant. Understood? So now this is just a general form to represent a polynomial, and we are having the condition for the power. I told you that n is the power or exponent of our variable. So now what is the n will be? N is a whole number. Okay, and your a0, a1, a2, what are all these? All these are your coefficients, and coefficients can be any real numbers. Okay, real numbers means you can take rational or irrational. Sometimes you will be getting the irrational numbers also, like your root 2. Okay, so sometimes you will be having 2x square minus root 2x plus 4 equals to 0. This is an equation, but of course if you don't consider 0, then it will become 2x square minus root 2x plus 4. Now the coefficient we are having as the irrational number, right? For that reason we are going to consider the power of the variable, which is the whole number, and your coefficients can be any real numbers. Okay, so simple, it is exponents or non-negative integers. Now let's discuss about the value and 0 of your polynomial. So what is this value and 0 of your polynomial? Value of your polynomial means I am having my polynomial in variable. Okay, for example, I am having p of x equals to 2x plus 3. This is your simple polynomial. Now I need to find the value of this polynomial at x equals to 2. Okay, At x equals to 2, I need to find the value of this polynomial. Okay, so now how we will find it? Just place 2, just replace your x with the value 2. Okay, so now what is this p of x will become? In the place of x, I need to keep 2. So p of 2 equals to, here don't get confused, it is 2x. 2x means 2 into x. Okay, some students will think of 2x means 2 plus x. No, we will be getting the 2x by multiplying 2 with x. So 2x means 2 into x. So that becomes your 2 into 2. Or if you are getting confusion, I can write 2 into 2 plus 3. Okay, now 2 2s are 4 plus 3, which is nothing but 7. So is it very tough? No, right? Just replace your x value with the given value. So I kept my 2 in the place of x. I got my polynomial value as the 7. Now, what is the 0? 0 means if you take this value and if you got the value of the polynomial as the 0. For example, I am having same p of x is equals to x plus 1. Okay, a simple example, p of x equals to x plus 1. Now, I need to find the 0 of this polynomial. Okay, so what we will do? First of all, take your polynomial, that is x plus 1, and equate it to the 0. Okay, now just do the transposition of your numbers. So plus 1 crossing equals to, it will become minus 1. So x value we got minus 1, right? It means what? If you take your x value as the minus 1 and if you keep that in the polynomial, then you will be getting the polynomial value as the 0. Let's see. Now, I need to find p of x at x equals to minus 1. Employs p of minus 1 equals to minus 1 plus 1, which is equals to 0. Yes, we got the polynomial value as the 0 by taking x equals to minus 1. Now, what is this minus 1? Now, minus 1 is the 0 of a polynomial. Okay, so simple. Value means replace your variable with the given number, and 0 means if you got 0 after replacing that number, then that number will become 0. Okay, that number will become the 0 of a polynomial. So after replacing the number, okay, after replacing your variable with the number, if you got the value of your polynomial as the 0, then that number will become the 0 of that polynomial. Okay, so you can just relate it so that you will be understanding very better. Okay, let's move to the next. Next is your degree. Very simple concept, but we are having applications. Don't worry. So now, if we are having the highest power, it means you are going to consider the highest exponent for the given polynomial as the degree of the polynomial. So simply, what is the degree? For a polynomial in one variable, you will be having a polynomial in one variable and highest exponent on the variable is the degree of the polynomial. Okay, for example, I am having x to the power 4 minus x plus 2. Okay, this is my polynomial and here I am having the three terms, that is your x to the power 4 minus x and plus 2. Now, if you observe here, what is the power of the variable here? Power of the variable is the 4 and here power of the variable. Okay, so power of the variable is the 1. Why? Because x is having the power 1. Why? I will tell you. If I am having x to the power 1, that is nothing but your x only. For that reason, the power of the variable x is the 1. And what about the 2? Some students will do another mistake here. That is, I am not having any number as the power here. So they will consider it as the 0. But no, because if I am having x to the power 0, then using your law of exponents, x to the power 0 will become 1. Right? But here I am having already variable x. So now the power of this x will become your x to the power 1. Okay. Now for the constant we can write 2 into 1. So 2 into x to the power 0. So now for these variable the power will become 0. Okay. Clear about when you will be getting the power of the variable as the 1 and power of the variable as the 0? For the constant, for the term constant, you are having the power of the variable as the 0. And for the term x, you are having the power of the variable as the 1. Okay, don't get confused everyone. So now, just compare the powers 4, 1 and 0. What is the highest one? Highest one is the 4. Then what is the degree will become? So simply degree equals to 4. Okay. So simply degree equals to 4. Okay. Now let's see what are the applications we can get. Degree of p plus q. It means what? I am having two polynomials, p of x and q of x. Okay. If I add those two or subtract those two, then degree of that resultant will be equals to or less than degree of p or degree of q. Okay. It means, I will explain with the example. P of x equals to x cube plus 3 and q of x equals to x plus 3. Okay. Or you can take x plus 8. Fine. I need to find degree of p plus q. So it means what? First of all, I need to add my polynomials p and q. So p plus q, what it will become? It will become x cube plus 3 plus x plus 8. So in algebraic expressions, we'll end about adding the like terms and adding the like terms and subtracting the like terms, right? So now the resultant will be x cube plus x, 3 plus 8 will be 11. Okay. So we got p plus q as the x cube plus x plus 11. Now what will be the degree here? Degree here will become, here it is 3 and here it is 1 and here it is 0. Okay. Now what is the highest power? 3. So degree of p plus q will become 3. Okay. Now what is the degree of p of x? 3. And degree of q of x? 1. So now try to just compare these one with our general statement. Okay. So degree of p plus q, which is 3. Okay. Less than or equals to degree of p or q, which is equals to our degree of p. Okay. So I got my degree of p plus q, which is equals to my degree of p. Clear? So generally we can say that degree of addition or subtraction of two polynomials will be less than or equals to degree of p or q. Fine. So just try to remember this. Next, degree of p into q is the degree of p plus degree of q. Here it will be, so degree of p into q. So now if you are multiplying x cube plus 3 into x plus 8 using distribution property, we are going to multiply x cube into x, right? So that becomes your x cube into x and so on. Fine. So it will become your once again x cube into 8 and next 3 into x and next 3 into 8. Now x cube into x, it is in the form of a to the power m into a to the power n. So we can write a to the power m plus n. So we will be getting x to the power 3 plus 1 plus 8x cube plus 3x plus 24. Okay. So that becomes your x to the power 4 plus 8x cube plus 3x plus 24. Now if you compare the powers of or exponents of the variable, then you can find degree of p into q as the 4, right? So simply we can say that if you take the degree of the polynomials which are in multiplication, then the resultant degree will be equals to the degree of the P and degree of the Q addition. Okay, you need to take the sum of the degree of P and degree of Q. Simple these two are. If you take an examples, then you can find those are very simple. Fine. Now, what about the note means? If I am having a polynomial with x cube plus 3, okay, here simply we can say that by looking at this, degree equals to 3, right? Now, can we relate the zeros of the polynomial to the degree? Yes, where number of zeros equals to degree. Okay, so if I am having the degree 3, then number of zeros also 3. Okay, and what about the factors? Factors means, can we factorize the polynomial? Yes, we can factorize the polynomials, like how we will do for the numbers. Simply we can take once again x square plus 2x. Okay, can we find the factors for that? Yes, we can find, where I can take my common term, common values outside. So I can take the x common, so it will become your x plus 2, where x is the factor and x plus 2 is also a factor, right? So polynomials can be factorized, and the number of factors of your polynomial is equals to the degree of the polynomial. Okay, so simply the relation between your degree, number of zeros and number of factors is, where number of factors equals to degree and number of zeros is also equals to degree. Okay, let's see the next. Now moving to the next is types of polynomials based on terms and based on degree also. Number of terms, for example, if I am having only one term, take x cube, only one term is there, so we are going to consider it as the monomial. Okay, and next I am having 2x plus x to the power 5. How many terms are there? 1 and 2. 2 terms are there, so this is binomial. Okay, and next if I am adding one more term, that becomes your 3x square plus 4x plus x to the power 8. Here I am having the 3 terms, so now this will be your trinomial. And next, multinomial or polynomial. Poly means simple term, we learned in science also, right? Poly means many. So now polynomial or multinomial means it will be having many terms. Okay, so simply polynomial means it will be having your many terms, right? Yes. Now what about the degree? Based on degree, we learned about the constant, right? Constant is simply a number which is of your 2, 3, 4, and if you expand this constant, what we got? We got 2 into 1, which is nothing but your 2 into x to the power 0, right? Now this degree, it means the highest power here is 0, so it is having the degree as the 0, so now the polynomial will become constant. Okay, and next linear. If you are having the degree as the 1, then it will become your linear. For example, x plus 3. Okay, now what is the power of the x? Here it is 1, right? So now I am having the degree of this polynomial as the 1, which will become your linear. And quadratic means degree is 2. Example we can take 2x square plus 4x plus 3. Okay, and next if degree is 3, it will become cubic, like your x cube minus x and so on. Okay, and if we are having the degree 4, then it will become your quintic. Quintic means you can say highest power we are having as the x to the power 4. Okay, now let's see, are we having any questions from the students? So explain the addition, subtraction and multiplication of two polynomials with examples. Okay, fine. So addition, subtraction, it will be the same. Fine. If you look at here, we have taken the p of x, x cube plus 3 and q of x plus 8. So we have taken the two different polynomials and we did the addition for the polynomials. So we got a polynomial as the x cube plus x plus 11. Now the degree of this polynomial is the 3 and degree of p of x is the 3 and q of x is the 3. So if you compare, I got the degree of degree of p plus q, which is equal to the degree of p of x. Okay, so simply in general terms we can write as the degree of p plus or minus q is less than or equals to degree of p plus degree of p or degree of q. Okay, simply if you are taking the addition or subtraction of two polynomials and if you find the degree of that polynomial, then you will be getting the degree less than or equals to either of that two polynomials. Okay, now simply coming to the multiplication also, I did the multiplication of two polynomials p and q here and I got my final polynomial as the x to the power 4 plus 8x cube plus 3x plus 24. For this polynomial, what is the highest power? The highest power is the 4. Okay, which is the addition of degree of the p and degree of the q. So simply in general statement, degree of p into q, it means if you multiply the two polynomials and if you take the degree of that, it will be equal to the sum of the degree of two polynomials. Okay, individually you need to take sum of the degree of the p and degree of q. Okay, yes. So okay, fine, let's see the next. Moving to the next, we are going to discuss about the graphical representation of a polynomial. So linear, just wait. How can we say or how can we take the graphical representation of any polynomial means? For example, if I am taking y equals to x plus 1. Oh, don't get confused. What is the y equals to x plus 1? I am taking my p of x, which is equals to x plus 1. It means I took my polynomial, which is the x plus 1, and I need to draw the graph for this polynomial. So what we will do, in order to plot the graph in our Cartesian plane, we need the coordinates, right? Yes, that we learned in our grade 9. For that coordinates, we need x coordinate and y coordinate. So how we will draw the graph here means, consider one variable. I have my polynomial in x. So what is the x will become? X will become your independent variable. It means what? You can take any random values for your x. Okay. Now I am going to take my dependent variable y and writing y in terms of your x. Okay. So now let's see. It would be better if you draw the table so that you can understand clearly. I will be taking my different values for the x and I am going to get my respective y value. Fine. So now if I take my x value as the 1, so what is the y will become? So y will become your 1 plus 1, which is nothing but 2. And 2, y will become your 3. Okay. So now I got my coordinates. So whatever the independent variable you are having here, x, that will become your x coordinate and dependent will become your y coordinate. So we got the points as the 1, 2 and 2, 3. Okay. So yes. Are we going to take the values randomly? Yes, that is correct. We are going to take the values randomly, but I will help you in this, where by taking your x value as the 0, you will be getting the respective y value, and by taking your y value as the 0, you will be getting your respective x value. Okay. It means what? By taking x equals to 0 means you are finding where that polynomial, okay, where that polynomial is going to intersect your y-axis. Okay. If x equals to 0 means it intersect y-axis. Okay. And if I am taking y equal to 0 means it intersect x-axis, right? Yes. Now, after taking x equals to 0, what is your y value? 1. And by taking your y equals to 0, what is the x value? -1. Why? Because you can take x as the 0, y equals to 0 plus 1, which is 1. And you need to equate y equals to 0. That means x plus 1 equals to 0. So, x equals to -1. So, we got 0, 1 and -1, 0. Here it is not 0, -1 because we need to follow the order of x coordinate and y coordinate. Okay. So, this is of your 0, 1 and here it is of your -1, 0. Fine. Now, plot these 2 points on the graph. And if you extend, you will be getting a graph. It means graphical representation of the given polynomial. Okay. This is how we are just going to graphically represent the given polynomial. Okay. If you are getting bored of taking random values, you can simply go for take x equals to 0 and find the respective y value, and take y equals to 0 and find the respective x value. So you will be getting where that graph is going to intersect your x-axis and y-axis. And if you just extend it, so you will be getting the complete graph. Okay. Now, what about the graph of your linear polynomial? So this is what the linear polynomial, right? X plus 1. Simply linear polynomial only. And now, if I plot 0, 1 and -1, 0. Let's try to plot on this. 0, 1. X is the 0 and 1 here. Okay. And next, -1, 0. So here it is, right? Now, if you try to join them, we got a straight line. Right? We got a straight line. Now, if you observe here, from this graph, we can say what is the 0 of the linear polynomial. How can we say? We are going to check the graph is going to intersect the x-axis at which point. So, here it is going to intersect the x-axis at -1. So, now -1, okay, -1 will become the 0 of p of x. Okay. So, without taking your polynomial to the 0, you can simply find the 0 of the polynomial from the graph by considering where the graph is intersecting your x-axis. Okay. Here the graph is intersecting the -1. So, what is this -1? -1 will become the 0 of the polynomial p of x. Okay. Now, the graph of your linear polynomial is always a straight line. Fine. So, whatever the linear you can take and try to take the different points and try to plot them on the graph. Then you can find the graph will be always a straight line. And next, it cuts the x-axis at exactly 1 point. Why? Because linear polynomial is having degree 1. So, 0 also will be 1. So, now linear polynomial is going to intersect the x-axis at 1 point. Okay. Now, let's see what are the questions we got. How will be the graph of the linear graph passing through origin? Okay. So, they are asking me to give me an example for the linear graph which is passing through the origin. Okay, nice. So, you are very attentive in the class here, because you found that I have given the graph which is passing through the origin. Very good. Now, let's see when we will be getting the case of a graph which is passing through the origin. Yes. So, we are having the equation y equals to x. Okay. So, let's take your polynomial p of x as the x. Okay. Now, what is your y will become? Y will become your polynomial x. Now, just find the respective values. So, x value and y value. If I am taking x1, then what is the y? 1. And x2, y2. So, we will be getting the coordinates. What are the coordinates here? Coordinates will become your 1, 1, 2, 2 and 3, 3 and so on. Right? Now, if you plot these points on your graph, then you can observe a straight line which is passing through the origin. Okay, so just plot them. 1 comma 1 will be here, and 2 comma 2 will be here, and 3 comma 3 will be here, and minus 1 comma minus 1, minus 2 comma minus 2, and minus 3 comma minus 3. Now try to plot them so that you will be getting a straight line. Fine. Ma'am, you are not getting a straight line. Yes, because I am not using the scale. But I suggest you please use the scale if you are plotting the graph for the linear graph. Then only you will be getting the exact zero of the polynomial. Okay. So finally we can say that for a linear graph, we are having the graph as the straight line, and next it cuts the x-axis at 1 point. Still any doubts for anyone? No? Okay, fine. Let's go for the quadratic then. Yes. Coming to the next is our quadratic polynomial. What will be the graph of the quadratic polynomial? Right? Now the graph of the quadratic polynomial is the parabola. Parabola means it's just a name of the shape, and you are going to learn about that in detail in your upcoming grades. So now just remember that the graph of your quadratic polynomial will be the parabola. It will be either upward parabola or downward parabola. Open upward or open downward. So simply you will think that it is just a U. Yes, remember like that only if it was easy for you. Okay. Now an open upward parabola. When you will be getting the open upward, a is greater than 0. What is this a? It is nothing but general form of quadratic polynomial will become ax square plus bx plus c. Fine. Why I am taking the general form means you need to think that okay, quadratic polynomial means I am having the degree 2. So general form will become ax square plus bx plus c, where I am having the degree 2, right? Now what is this a? A is nothing but coefficient of x square. If you are having the coefficient of x square greater than 0, then you will be getting the open upward parabola. Okay, and if the coefficient of x square is less than 0, then you will be getting the open downward parabola. Now look at the diagrams. All these are open upward only. It means I am having my coefficient of x square is greater than 0. Simple, right? So I am having the coefficient of my x square is greater than 0 for all these three graphs. What about the a less than 0? Very simple. So how I have taken the open upward? Take the open downward. If you extend, so you will be getting the 2 points, right? Where this parabola is going to intersect our x-axis. Actually this is your x-axis only. Fine, try to remember the coordinate geometry of your grade 9 for the graphical representation, so that you will understand x-axis, y-axis, origin. Now coming to the next, for these also, this is for a less than 0, and in the same case we are having a less than 0, graph will be touching our x-axis at only 1 point. Okay, and next we are having a less than 0 where it is open upward, open downward. Fine, but it is not touching the x-axis. Means what? It is not having the 0. Okay, let's discuss. First of all, if you observe here, a is greater than 0, we got open upward, and if you take the graph, then you can observe it is intersecting the x-axis at 2 points. Okay, so these two can be the 0, and we are having another parabola which is touching our x-axis at only 1 point. It means I will give you an example. X square plus 4x plus 4. Okay, this is my quadratic polynomial. Fine. After doing the factorization, okay, after doing the factorization, so 4x, it is the 4x. After doing the factorization, I got it as the x plus 2 whole square. Okay, now what are the factors will become? So factors will become your x plus 2 into x plus 2, right? I am having the same value 2, but x plus 2 is the repeated one. It means what? I am having the two roots, but those two roots, it means those two zeros are equal value. Okay, now understood everyone? So now I am having the two zeros for my quadratic polynomial, and I am having those two zeros are of equal value. So how can we say about those zeros? Means we need to learn about the discriminant. Okay, so we need to learn about the discriminant. Clear? So discriminant is nothing but simply it is the value given by b square minus 4ac. Fine. How can we find the BAC values? For example, I have given a polynomial x square plus 5x plus 6. This is the quadratic polynomial I am giving to you. Now, compare this polynomial with the standard form. Okay. So, after comparison, ax square plus bx plus c, our a value is the 1 and b value is the 5 and c value is the 6. Okay. Now place that values in the discriminant. So what you will be getting? B square, 5 square minus 4 into 1 into c is your 6. So 5 square is the 25 minus 4 6 is the 24, which is the 1. Okay. So these discriminant is represented by det or d. You can take your small det symbol, or you can take capital D also. Now, depending upon the type of value you are getting for the discriminant, you are going to say what type of zeros you are having. Okay, let's see. If I am having my discriminant, okay, discriminant is greater than 0. Is greater than 0. It means what? You will be having plus 1 plus 2 like that, whatever the positive integers you are having. If you are having discriminant greater than 0, then your two roots, actually quadratic polynomial means we are having the two zeros, but those two zeros are real values and distinct values. It means some separate values. Okay. Now, if you are having that discriminant equals to 0, then you are having the two roots. Okay. Those are real roots, but the roots are equal. Like now we got two factors x plus 2 and x plus 2, but here the zeros are same. Okay. And if you are having discriminant is less than 0, okay, now we will be getting the complex roots. Complex roots. So what is these complex roots? That we will discuss in our quadratic equations. But you can remember that if I am having discriminant value, based on the discriminant value, what type of roots we are getting? Okay. If discriminant is greater than 0, real and distinct. Okay. And if discriminant is 0, we are having the real roots but equal. Okay. And if you are having discriminant less than 0, you will be getting the complex roots. Okay. You are having the 0, but you are having the zeros for the quadratic polynomial, but those are the complex roots. Okay. Now, how can we, what can we conclude from the graph of a quadratic polynomial? Means the graph will cut the x-axis in at least one point. You can observe here, it is going to cut the x-axis at least one point, minimum 1 point, and maximum is your 2 points. Okay, understood everyone? Yes. Now let's go for the next. Now moving to the next is our cubic polynomial. So the graph of a cubic polynomial, if we want to discuss, take the some of your examples. Like I am taking y equals to x cube minus x. Okay, let's factorize it. So what I am getting? X into x minus 1. X square minus 1 I am getting. I am taking x common. So I am getting x into x square minus 1. And once again, x square minus 1. It is in the form of a square minus b square. So I can write it as a minus b into a plus b. Okay. Now from these, what are the zeros will become? X equals to 0, x equals to 1 and x equals to minus 1. right? These three are the zeros of your cubic polynomial, right? Now, if you take the graph of that cubic polynomial, then you can observe that the graph will intersect the x-axis at the 3 points and at most 1 point, okay? So at least 1 point will be your minimum value where the graph will intersect the x-axis, and it is going to intersect at the 3 points which is the maximum value, okay? Now let's see the questions from the students, okay? How will be the graph of a cubic polynomial with 1 0? 1 0, it means you can take the simple example that we have taken for the linear polynomial which is passing through origin. Y equals to x cube you can take, okay? Now you can get different values for your y and x, right? Where x and y, fine, just take 1, so it will be 1, and -1 -1 and 2, and it is 8, right? And so on. Now try to plot them on the graph. So how the graph will be means, you will be getting a cubic polynomial which is just, okay, which is just going to intersect your x-axis at the origin. Clear? This is your x-axis and this is your y-axis. Of course, you will be getting some curve shape, and you are getting that curve is going to intersect at the origin. 1 0 means it is going to intersect at only 1 point, and sometimes you will be getting the graph of your cubic polynomial as like this. So now what happened here? Here also the graph is intersecting the x-axis at 1 point. Clear? So now coming to here, we can conclude for the cubic polynomial that we are not going to say a particular defined shape, but we can say that how many zeros it is having. Like it is having at least 1 point, that means 1 0, and at most 3 points, that is your 3 zeros. Okay? Now, moving to the next, we will discuss about the relation between the zeros and coefficients of a polynomial. So now you understood why I kept that much discussion on the coefficients, because we are going to solve, or we are going to learn in detail about the relation between the zeros also. Like how can, if zeros are given or if coefficients are given, how to find the another one. That is the basic important concept for your exam. Okay. So for that reason, we need to concentrate on the coefficients of the polynomial. If you are okay with finding the coefficients, then it will be very easy for you. Clear? Yes. Now let's see what will be the relation between the coefficients and zeros for the quadratic polynomial. Okay. Now what is the general form? General form is your ax square plus bx plus c. As it is a quadratic polynomial, after factorization, you will be getting it as the x plus alpha into x plus beta, where alpha and beta are the two roots. Okay, so like how we got x square plus 4x plus 4, right? After factorization, we got x plus 2 into x plus 2. Clear? Now, what is these two? 2 and 2. Here we will be getting the zeros as the -2, -2. Right? So we got the two zeros as the -2 and -2. So now what is the relation between those zeros and the coefficients of the polynomial means? If you take the sum of these zeros, alpha plus beta equals to minus b by a, and product of zeros is equals to alpha into beta, which is equals to c by a. Okay, so now let's check. -2 plus of -2, right, which is equals to your -4, right? Now minus b by a, so alpha plus beta I got -4. What about the minus b by a? If you compare, a value is the 1 and b value is the 4 and c value is the 4. So what is the b by minus b by a? So minus b by a equals to -4 by 1, which is equals to -4. So alpha plus beta we got -4 and minus b by a we got as the minus 4. So sum of zeros is equals to minus b by a. And what about the product of zeros? Minus 2 into minus 2, that is your plus 4, and c by a. Okay, c by a will be equals to c is the 4 and a is the 1. So which is nothing but your 4. So we got product of zeros equals to c by a. Very simple, right? Sum of the zeros minus b by a and product of the zeros c by a. Now, same thing for our cubic polynomial also. Cubic polynomial standard form will become ax cube plus bx square plus cx plus d. If I am considering all the variables, like variables with the decreasing powers, then it will become your ax cube plus bx square plus cx plus d. And after factorization, we will be getting x plus alpha into x plus beta into x plus gamma. Okay, where these three are the factors of your polynomial. And if you equate x plus alpha, so now what is this alpha beta gamma will become zeros of the polynomial. Now relation will become sum of zeros equals to same minus b by a and sum of product of two zeros, that is your alpha beta plus beta gamma plus gamma alpha equals to minus c by a. Okay, and product of the zeros alpha beta gamma equals to minus d by a. Okay, yes. So still any doubts for anyone? Fine, that's nice. If you are taking notes, you can just take a note of these simple points. Sum of zeros, that is your alpha plus beta equals to minus b by a. Don't take the entire sentence because we are having only limited time. So it will be not possible for you to to take the complete notes. Okay. And if you are unable to take that short notes also, don't worry, we will provide you. Fine. And we will discuss about that. Wait. Now, we discussed about the relation between the coefficients and zeros of your polynomial. For the quadratic, sum of zeros will be equals to minus b by a and product of zeros equals to c by a. And for cubic, sum of zeros equals to minus b by a and sum of product of two zeros will be equals to c by a and product of roots will be equals to minus d by a. Okay. Now let's discuss, it means division algorithm we are having in our grade 9, right? We have already completed about the division of polynomials, which is the toughest topic in the polynomials when you are studying in the grade 9. I have seen so many students saying that division of polynomials is the toughest, ma'am. But it's not that much toughest because when you understand the process, then it will be easy for you to apply the same process for all the questions. Okay? Now, what is the division algorithm? Basic division algorithm we are having. That is dividend equals to divisor into quotient plus remainder. Same. P of x, that is my polynomial 1. P of x if I am dividing with Q of x. Or if you get confused, you can take that f of x. Okay? F of x you can take if you are getting confused. Clear? Now, this is my dividend, right? I need to divide this polynomial. I need to divide this polynomial. So what is the f of x will become? Minus x cube plus 3x square minus 3x plus 5. Okay, this is my dividend. Now what is the divisor here? P of x equals to minus x square plus x minus 1. Clear? Now what is your first step in your division of polynomial means? First of all you need to check the degree of divisor. Okay, you need to compare the degree of divisor should be less than or equals to your degree of dividend. Okay, so degree of your divisor should be less than or equals to your degree of dividend. Then only we can go for the long division method. Clear? Now, coming to here, what is the steps means? First of all, take the first term of the divisor and the dividend. That is your minus x cube by, what is here? Minus x square. Okay. Now, after taking the first term of your dividend and divisor, just divide them, cancel them. So what you will be getting? X. So on dividing the first term of dividend with the first term of divisor will give you the first term of the quotient. Okay. So here what is the quotient? First term we got X. Now multiply each and every term of your divisor with the first term of the quotient. That means minus x square multiplied with x. So we got minus x cube, and plus x multiplied with x plus x square, and minus 1 multiplied with x. So we got minus x. Okay. Now let's see. This is your one of the polynomial and this is the another polynomial. Now you need to carefully check whether you need to add or subtract so that your first terms will get cancelled. So if I am adding minus x cube, that means your 2x cube, right? Now I am doing the subtraction. So minus will become plus, and plus will become minus, and minus will become plus. Okay, so that plus x cube minus x cube will get cancelled. But initially you thought how we can cancel minus x cube and minus x cube. By taking the subtraction of these two polynomials only, you can cancel your highest power, like highest exponent term. Okay, so after taking the subtraction, minus will become plus. So minus x cube and plus x cube will get cancelled. And here 3x square minus x square, 2x square, and minus 3x plus x minus 2x. Now bring this 5 down. So it will become your plus 5. Now what is the next step? The same. Coming to here, you need to take the first term of this expression. That becomes your 2x square by divide the first term of this expression with the first term of the divisor. That becomes 2x square by minus x square. X square cancel. So we got minus 2, which is the second term of your quotient. Okay. Now repeat the same process. Multiply each and every term of your divisor with the second term. So minus x square into minus 2 plus 2x square, and next plus x into minus 2 minus 2x minus 1 into minus 2, so that becomes your plus 2. Okay. Now once again, I need to eliminate this first term. How can we eliminate? We need to take addition or subtraction. That we need to check. Okay. That is the important thing you need to check, is whether we have to do the addition or subtraction. Clear? Now if I am taking addition, 2 plus 2 will become 4. So I can't take the addition. Now what we will take? Subtraction. Now plus 2x square will become minus 2x square, and here minus 2x will become plus 2x, and plus 2 will become minus 2. Now 2x square cancel. Plus 2x minus 2x once again cancel. 5 minus 2 will give you 3. So finally we got the remainder as the 3. Okay. So here we completed the division within few steps, right? But for some of the questions it will be somehow extension. Don't worry about that. If you understand the concept, then you can go on till you are getting the remainder. Fine. Then how can we identify the remainder? You will be getting a remainder which is equals to 0, or your degree of the remainder r of x is less than your degree of p of x. Okay. It means you are getting the degree of your remainder less than degree of the divisor. Okay. Here I got the remainder 3, right, which is having the degree less than your divisor. Clear? Yes. So some students will think that, oh my god, this is a long process, and if you got the questions in the MCQ, you can't spend this much time, right? Then you can go for the synthetic division, which you can mostly use for the starting of your cubic polynomials. Okay. From the cubic polynomials, you can start using the synthetic division in order to save some of your time in your exam. Okay. For example, here I am having 27 minus 81, 85, 23. What are these? These are all coefficients. Okay. Now, what will be the polynomial means? 27x cube minus 81x square plus 45x plus 23. Okay. Now, what about this x equals to 2? X equals to 2 means what? This is the 0. Fine. This is the 0 of your given cubic polynomial. Clear? How can we find that 0? Just take your coefficient of variable with the highest power, that is your 27 multiplied by 23. Your constant. Okay, some of the students will start taking the values of the x and they will place them, so that will be a long process. If you want, you can go for this. You can take your coefficient of highest power and multiply with constant, so from there you can find one of the 0. And now what we will do, first of all, we got one of the 0, right? Now just take the 27, below the 27 keep the 0. Now just add them. So what we will be getting, 27 plus 0 is the 27. Okay. Now multiply 27 with this 2. 27 into 2 will give you 54. Once again add these two values. What you will be getting? So we will be getting here minus 27. Now once again multiply this minus 27 into 2, minus 54. Now 45 minus 54 will give you minus 9. Once again multiply this minus 9 with the 2. So we got minus 18. 23 minus 18 will give you 5. Right? Now what we got here means, whatever the cubic polynomial we are having, we are just reducing that cubic polynomial to your, polynomial to your quadratic polynomial. This 27 minus 9, these will tell you the coefficients of one of your quadratic polynomial. Okay, so that becomes your 27x square minus 27x minus 9. Clear? Understood everyone? So now after factorization you will be getting the remaining two zeros. Clear? It means we will be getting the remainder from your last row. From your last column, you will be getting the remainder whenever you are subtracting a cubic polynomial with the given polynomial. Here x equals to 2, it means what? X plus 2 is your divisor. Okay, so x plus 2 is your divisor. So as I am having x equals to 2, then it will become your x minus 2. How can we say that means? It's very simple. X equals to 2. It means what? You are taking the x value as the 2. Then what is its factor will become? X equals to 2 means its factor will become x minus 2. It means we are dividing this complete polynomial with the x minus 2. Okay? Yes. Understood? Now, let's see the questions. How can we find one of the 0 of the cubic polynomial? So when it comes to your division process, you can take the coefficient of the highest exponent variable. That is, take the coefficient of your highest exponent on the variable, and take your constant. Now multiply these two values and you can find the factors for that value, right? Now from there you can find the one of the 0 if you want to factorize the cubic polynomial. But when it comes to your division of polynomials, they will give you the dividend and divisor. Coming to the factorization, see, don't get confused. Synthetic division you can use for division of polynomials, and next you can use for factorization of your cubic polynomial also. Division of polynomial means simply they will give the divisor and the dividend also. If it comes to your factorization of cubic polynomial, first you need to find the one of the factor. How can we find that one of the factor means? Multiply coefficient of your term with the highest power with constant. So from there you will be getting the one of the factor. Okay, now divide that with the polynomial. If you find one of the factor of your cubic polynomial, then you will be getting the remainder 0. That you need to understand. Okay, here I got my remainder as the 5. So x equals to 2 is not a factor. Understood? For this polynomial, I need to divide with this polynomial. That's it. Okay. So synthetic division you can apply for your factorization of cubic polynomial and division of polynomials. Okay. If you got this remainder as the 0, then this value will become a factor. If you are not getting this value as the 0, then it is just a divisor. Clear? Yes. And next, what we do after getting the coefficients from the synthetic division, that's what I told here. Whenever you are doing the factorization of cubic polynomial, you got the coefficients of the polynomial of the quadratic. Okay, here we got the coefficients of your quadratic polynomial. Now you need to factorize it so that you will be getting the remainder two factors. Remaining two factors you will be getting. Okay. Yes. Now, okay, fine. Let's go for the next. Moving to the next, we will discuss about the division algorithm. That means application of division algorithm, factor theorem and remainder theorem. So what is the factor theorem means? We can say that x minus a is a factor only if p of a equals to 0. It means simply I can say that x minus 2 is a factor of x square plus, or you can take x square minus 4x plus 4. Okay, x minus 2 is a factor of x square minus 4x plus 4. When we can say that means you need to find, okay, you need to find the x value. That means your 0 value. X minus 2 equals to 0 value where you got x equals to 2. You need to place the 2 in the polynomial. So after placing that, if you got the polynomial value as the 0, then it becomes your factor. Clear? If I am having x minus a as the factor, then you will be taking a as the 0 only when p of a equals to 0. And x minus a is a factor if p of a equals to 0 and a is the 0 of the polynomial. Okay, the relation is very simple, don't get confused. Value of polynomial, factor, and a will be the 0. That's it. It means x minus a is factor means we will be getting the p of a value as the 0. From this, a is 0 of p of x. A is 0 of p of x. Factor theorem is very simple. We just need to check whether the given polynomial is the factor of the another polynomial or not. How can we check? Take the 0 from that given factor and place that 0 in the polynomial. If you got the polynomial value as the 0, then the given polynomial will become the factor. Okay. Now, if I am taking x minus 2, this is a factor. From this, x equals to 2 I got, which is the 0. Now place that here, 2 square plus 4 into 2 plus 4. Okay, 2 square will be the 4 and 8 plus 4. Now 12 plus 4, 16. So I got the value as the 16. So this is not a factor. Okay, not a factor of, consider this is your g of x and this is your p of x. So we can say that g of x is not a factor of p of x because I didn't got my p of a value as the 0. This is not equals to 0, right? Understood everyone? Now take p of x equals to x square minus 4. Okay, and g of x is equals to x minus 2. Clear? And from these, compare it with x minus a. What is your a value? A value will become 2, right? Now find the p of a. So p of a equals to 2 square minus 4. 2 square is the 4 minus 4, which is equals to 0, right? So I got my p of a equals to 0 by taking my a value is the 2, which is given by the factor x minus 2. So simply we can say that x minus 2 is a factor of p of x. Clear? X minus 2 is a factor of p of x. Now Coming to the remainder theorem, if p of x is divided by x plus a, then remainder is given by p of a. Okay, then the remainder will be the p of a. Now look at this example, same example, x minus 2, if I am dividing my p of x with g of x, if I am dividing my p of x with g of x, then what will be the remainder? So remainder will become, you need to find the 0 from your g of x. That means x minus 2 equals to 0, x equals to 2. Now this is your a value, right? A value we got as the 2. Now place that value in your p of x. So what is the remainder will become? So remainder will become 16. Clear? Simple. The thing is, if x minus a is a factor, p of a will become 0. Now a will become the 0 of p of x. Then what about the remainder? If p of a is not equals to 0, okay, if I am having p of x and g of x equals to x minus a, okay, now if I am dividing p of x with g of x, that is I am dividing a polynomial with the another polynomial, then what is the remainder will become? Remainder will become your p of a. Simple. Clear? Sometimes you will be getting the remainder as the 0. If you got the remainder as the 0, then it will become a factor. How can we find the remainder? If your polynomial is divided by another polynomial, means you need to take the value of x and just replace x with that value and you will be getting a remainder. Fine. So now if that remainder is equals to 0, then we will be getting, if that remainder equals to 0, then g of x will become the factor. Okay, let's solve, let's clear one of the doubt. Is there any relation between the factor theorem and remainder theorem? Yes, we are having a relation. So by taking your g of x as the x minus a, you are going to find the remainder p of a. If you got that p of a, is equals to 0, then we can write g of x is factor of p of x. Okay, if you got that remainder as the 0, we can write that g of x is factor of p of x. Clear everyone? Yes. Now I think it's almost all time is completed. So we will end the today's session here, and in our tomorrow's session, like in our next session, whatever it will be, so we are just going to discuss about the problems related to the polynomials. Meanwhile, what you have to do? You have to once again go through the material that is available with you for this video and take a short notes and get ready with the formulas and get ready with the content that required for the solving the problems. Okay, so that's all for today's session. Bye everyone. Take care.